Thanks everyone for coming out. I know that everyone had lots of choices tonight on either watching the oldest people in history debate on TV or come here for our meetup. Yeah, boy, touche. I feel hurt by that comment, but yeah, so thanks for coming out to Bleeding Edge Web. If this is your first time out, especially welcome. We normally give a little intro news from the Bleeding Edge talk for the first 15 minutes or so, and then I'll hand it over to Kyle here, talk about the root of all web evils. So I'm very excited about that. Kyle actually has spoken at our meetup before, but it's been probably 5 years or so, pre-COVID for sure. 2018, 2019, probably 2018. So glad to have Kyle back. Just a little bit of housekeeping. So actually, by the way, I'm sure you've all seen the food by now. Please eat up, drink up. In the spirit of the upcoming 4th of July, I bought some patriotic cupcakes back there, so please eat those. We have a Slack channel, so if you want to follow up after the meetup, please join us there. Everything is on our website, edgeatx.org. Of course, we're always interested in speakers. You don't have to be an expert to speak. We also love lightning talks. We love people who have side projects to come out, show us what we're working on. And if your company is interested in ever sponsoring, paying for the pizza to help us out, that would be great. Just let us know. Feel free to come reach out to me afterwards as well. We'll chat about any of that. As always, thanks to our host, Expedia. And I think Rod wanted to just say a word here for having us, Rod.
Yeah, super happy to do this. We've been hosting for several months now, and it's been awesome. We actually have a bunch of Expedia people here today. If you work or an intern here at Expedia, will you raise your hand so everybody can see you? Come on, guys, don't be shy. There we go. Any of these people, feel free to talk to them about this place. But we are in this new building for several years now and have this great space when to do it. I just want to take a minute to say, very excited to have Kyle here. I met Kyle years ago at an event like this, and when I was getting into tech, reading his books and all of his, even your tweets, Kyle, I would read those for better or worse. Yeah, seriously. And I got rid of my tech Twitter, so I'm sorry, that's in the past. But yeah, I'm just very excited that Kyle's here with us and able to be here and talk. So pumped to be sitting alongside you. So thanks to everyone.
Yeah, like I said, thanks a lot to Rod and Expedia. Couldn't do this without the awesome location. So I'm going to just jump right into it. Actually, before I do, I met a couple of people before the talk started who are entry-level folks who are looking for jobs. I'm just curious, is anyone out there hiring or know of anyone who's hiring for like entry-level web application development? Is anyone like looking, aside from the people I talked to, is anyone else looking for jobs? A couple of people back there. Oh, really? All right, well, I did mean to mention in the first part too that, you know, part of the beauty of coming out here in real life, in person, and meeting people is to have these conversations and get to know other people. So we'll have time afterwards. Please do stick around and chat with other folks. So some library and framework news. So normally in this section, I talk about things that have just come out and been released. There's actually an interesting headline about something that has not been released, which is React 19. So if you follow React at all, it got to the point where they were at the release candidate stage and very close to shipping it. And a subtle change that actually was in the release notes, ironically, but I guess no one noticed it, just got noticed recently. And it's basically that in this feature of React called suspense, when you have child components that load data, all up until this RC version change, each of those components would load in parallel. So you could kick off all 3 of those child components, they would all run at the same time, and then the suspense boundary would sort of execute and render once those were all loaded. Well, in the release candidate version, they changed that so that those child components load in sequence, which may sound like maybe not that big of a deal, but a lot of people thought it was a big deal because a lot of people rely on that pattern, and it drastically slowed that down if you use that pattern. And in fact, more importantly, there's some data management libraries in the React ecosystem that also kind of rely on that. So predictably, the internet was not happy about that. Long story short, there was a bunch of back and forth. The React team finally relented. They still don't like that pattern and want people not to do it that way, but they basically decided that they're going to not try to break the internet. So they're going to fix that. So I just thought that was interesting, sort of non-release news. If you follow this survey that's been going out for years, the State of JS, this one just got published June 23rd. A few little nuggets from it. The most liked kind of tools and libraries that people voted on were these. Beat, if you haven't gotten into it, it's got super high mind share right now. A lot of people really love it. The DX of it is very good. I haven't used it yet actually myself, but a lot of people talking about it very positively. The most hated, Gatsby, which I found surprising because it's actually just like a static site generator. So I'm not sure why people hate it so much. Angular and Selenium and Webpack, I can definitely get behind. So you understand those. In the non-JS space, Python, PHP, and Java are the most popular languages. But there's a ton of stuff in there. If you haven't looked at it, there's a lot of demographic information about developers, and what our industry looks like. It's actually pretty interesting. There's also a state of HTML report. And just a little note, if you notice that this is the state of JS 2023, you might be wondering, well, it came out on June 23rd of 2024, which seems pretty late. There's actually this whole Reddit thread with people complaining for the last several months about when is it going to come out? Why hasn't it come out? And the guy behind the survey actually wrote a response talking about how he had been burnt out and, kind of probably resonates with anyone who's done open source before or had, basically started a project like this that became very successful. And then all of a sudden the spotlight's on you and people have expectations. So a little interesting thread on that. A few other notable releases, if you happen to use any of these libraries, HTMX 2.0, we just had a talk a few months ago here about HTMX. So that's pretty cool. And then baseline news. So if you were here at the meetup last month, I talked about Baseline, which is a relatively new thing. It's kind of a collaboration among the primary vendors of the browsers where they've finally, after all these years, sort of come together to, instead of just throwing out random canary features that no one was expecting, they thought finally it was a good idea to collaborate a little bit on these features and try to come together and ship things, more along the same lines, which is really helpful, and more along the lines of trying to follow the specs as well. So they have this concept called Baseline now. Newly available means that all the core browsers have actually shipped support for it in some form. And then once it's been out for a couple of years, then we call it widely available. And you can pretty much assume that your users will be able to use it. And then, the core browsers are the ones you would suspect: Chrome, Firefox, Safari, Edge. And this is relevant because we just had major browser releases. So on June 11th, actually, both Firefox and Chrome had releases. And of course, if you follow Chrome at all, that also means that Microsoft Edge and Opera kind of share the same engine. So it's been interesting because, Firefox back in the day sort of led the charge a lot of times on innovation. And we, thank them for that historically. Nowadays, they tend to be the laggard, probably because of resources or whatever. But a lot of times when things sort of make it into Baseline, it's because Firefox has finally shipped that particular feature. So one example of that is set methods. So if you have the need to do any kind of, set operations in JavaScript, you have a lot of nice new methods to do that with. Those are in all the core browsers. We also have the async clipboard API. So the clipboard API in general is not a new thing. So for many years, we've been able to do this command called exec command, which is like a low-level API. And actually, it does more than just clipboard stuff, all kinds of low-level browser stuff. But it's deprecated. It's not really recommended. It's also synchronous, which means especially for copy-paste, it can be really slow depending on the size of your content. So we now have these asynchronous methods, read and write, which do exactly what you would expect. And then you also have access to these events so that when something is copied or pasted, you can actually intercept that event and customize how the operation works, which is pretty cool. So learn more about that if that sounds interesting. And then Safari 18. So we don't normally talk about beta releases in terms of Baseline because it hasn't shipped, to production. It's not really Baseline. But I thought it was worth mentioning, if you follow WWDC, which just happened a week or two ago, Apple announced all their developer stuff. it is a time when they're putting out a lot of stuff. They're putting out new versions of all their operating systems. New iPhones are about to come out. Vision Pro just came out. So, one of the big things they're pushing, of course, in addition to AI, which I'm not mentioning, is all the VR stuff, right? So they have support now for WebXR, hand tracking in the browser, which is cool, CSS view transitions, and some other things. I mentioned writing suggestions. That's one to sort of be familiar with. So that's basically an attribute that controls whether when you start typing into a text field, if it will prompt with like suggested completion for whatever you're typing. The reason I mention it is because it will be on by default in Safari 18. So if you happen to be developing some form and you notice that's happening, that's something to be aware of, that you would want to turn that off if you don't want that. So just FYI. There's actually a ton of stuff in that release. So if you support Safari at all with the stuff that you work on, you might take a look at that. There's a ton of stuff in the release notes to be aware of. And then I wanted to highlight a couple of interesting deprecations that I found interesting. Again, Kyle made the joke that maybe just he and I are like the old guys in the room. There's probably a few other old guys in the room. There's a image format called JPEG 2000. And it's called that because when it came out, it was looking forward to the year 2000 when it was going to be the hot stuff. It never really took off. It actually is very commonly supported in graphics editor applications like Photoshop and all those, but it never really took off as a browser image format. So they're removing that one if you care about that. And then the KHTML drag pseudo class has been deprecated. So when I saw that, it prompted me to put a little history pop quiz question here. Who knows what KHTML actually even is? Why is that an attribute? All right, from the back row, we have a winner. Web History Spotlight. I thought this was interesting. So there's a thing called KHTML that many people probably either don't know about or have forgotten about. KHTML was actually the browser engine for KDE Conqueror, KDE being an old Unix desktop that was really popular. Probably it's still around, but kind of became really popular in the late 90s. Conqueror was the browser for it. HTML was the browser engine. Conqueror as a browser, of course, peaked at about 0% market share because it was a niche kind of Unix thing that most people didn't care about. But in 2002, Apple actually forked KHTML to create the first version of WebKit, which a lot of people may not know about. In more recent history, Google forked WebKit to create Blink. And Blink is the underlying engine that now powers Chromium, which now powers Chrome, Edge, Opera. So 93+%, depending on the stats that you look at, of browsers today actually descend from KHTML as the original rendering engine. So the more you know, it's pretty cool. I sort of knew all that, but I hadn't actually ever just kind of laid it out in those terms. Yeah, it's pretty interesting. And then along those lines, I separately ran across this visual history of browsers, which is pretty cool. So this is basically every single browser. Many of them I've never heard of. But if you sort of zoom into this little part, this is where we're talking about where KDE started, and then Apple forked WebKit here, and then now we're at Chrome over here. But this basically is a history of all browsers sort of shown by market share. Kind of interesting. All right. A quick web standard spotlight, because actually as of yesterday, TC39 approved ES 2024, ECMAScript 2024, which is the specification for JavaScript. There's actually a lot of stuff in it. Most of it is minor / very techie stuff that you may not care about. The map and object group by, that's a fairly practical thing. That basically allows you to take an array of keys and sort of programmatically map them to values using a function. It's a niche thing, but there may be use cases for that. Promise with resolvers is basically a way to just extract the functions like the success and rejection functions from a promise and use them independently of callback. Again, if you don't use promises, don't worry about it. The regex one is actually a practical one, though. If you deal with Unicode at all, you're probably familiar with the /u flag that you can use on regexes. So that basically is a way to tell it to handle Unicode and extended character range things correctly in regex. There's a lot of bugs in the current implementation of that /u flag. So this new one /v, which is of course one letter more than u, it's the upgraded version basically of that flag. They actually recommend now that that should be your default flag that you use if you deal with Unicode at all. This is well-formed, too well-formed. That is a very techy, very niche thing that's also sort of like a Unicode bug fixy type thing that you probably don't care about. But if you're interested, you can follow the links. Array buffer stuff, wait async, again, that's like memory management, internal stuff that normal humans won't really care about. The interesting thing about this list, though, is that every single thing on the list, aside from the asterisk items, are already in baseline. So we talked about baseline. That means that every core browser that we care about today has these APIs in them. The exceptions being array buffer resize, which is actually coming out in the next version of Firefox. And then this wait async thing is not announced yet for Firefox, but again, you probably don't care about it. In case you missed it, everything's AI these days. I'm sure you haven't missed AI. Well, there's this new thing in Chrome that you may not have seen. So basically, there's this whole page that you can go read up about it. I'll just show you what it is. So they have this demo page that you can go to, get out of full screen. Oh, not gonna let me load. All right, well, I can just show you what it looks like here. So the demo creates an artificial error so that you can sort of walk through like the actual error explanation in a controlled way. But I can show you kind of the concept of it. I'm not sure why their app isn't loading. So when you're looking at the console in Chrome now, if you hover over an error, now you get this little light bulb kind of thing. Let me zoom that a little more. So if you can see that, you get this little light bulb that says understand this warning. If you click on that, I get prompted. And of course, it's a bunch of legalese. So you're signing away your soul so that you can pull AI into your browser. And it's AI, it's this Gemini. You've probably heard of Gemini from the snafus actually that they had a few weeks ago about how terrible its recommendations were. But you can try it out and totally trust it. And the funny thing is, of course, it's got disclaimers all over the place. Actually, on my slide, I read this disclaimer as part of what I agreed to. It says, sometimes the responses produced sound convincing, but are actually misleading or meaningless to a human web developer. So, take it with a grain of salt. But of course, everything has to be AI these days. So Chrome has AI. So there you go. And last but not least, this is really cool. So if you're ever into code golf, or there's millions of examples of people writing super obscure JavaScript to do cool things. This is one that I ran across, it was worth linking, not necessarily because the thing itself is the coolest thing I've ever seen, but this is an example of someone who actually provided a YouTube video where he walked through the code line by line and kind of breaks down exactly what each character of the script does, so that as you walk through it with him, you can sort of understand how to construct a similar type of program, which is really cool. And it's only 10 minutes. So it's very informative. And then the other cool thing about it is that, I don't know if it's the same guy who built this, but there's this site called Twitter, which I had never run across before. Has anyone ever seen Twitter? So it's like a Twitter, but specifically for 140 character or less JavaScript programs. So this is the full program. Let me zoom this for you. So this is the image. This is the program in its entirety that generates this image programmatically, and you can play around with it in the browser. So as I change the text, I can change the variables of what this thing does, and I can play around with it. And so it's a great learning tool if you're interested in this kind of stuff. So it's like, pretty simple canvas type stuff with some pretty, not super complicated, but like if you can understand basically sine and cosine, you're 90% of the way there. And then it's just a matter of like dealing with how to make JavaScript work with very few characters. But anyway, it's a really cool resource. Check it out. And I will close with my personal favorite because I looked through a bunch of these tweets and I ran across this one, which is just kind of mesmerizing. Honestly, I watched it for like 5 minutes and it's 139 characters of JavaScript code. So go check it out. Enjoy. A lot of fun. And with that, thank you very much. And I'm going to hand it over to Kyle. Thanks, y'all.
Four hours. Pretty good. All right. Everyone hear me all right? And the couple of folks that are braving the online experience, hopefully you can hear as well. We've got a screen sharing here. Yeah, so let me do a couple of intro things before I jump into what I'm going to speak about tonight. So first of all, thank you all to the organizers for bringing me back out. It has been like almost 6.5 years since I was at the meetup. So I'm sure a lot's happened with the web. I don't know, I'm still trying to catch up, but a lot's changed over the web. But it's cool that this meetup, you know, there was definitely a downturn. You know, there was some worldwide pandemic thing that the downturn for a lot of meetups, but it's great to see people back in person, people collaborating, all the conversations that are going on. I've already heard some really interesting stuff going on. So I'm thrilled to see that. My experience with meetups here in Austin goes way back to about 2007. I started going to the first meetups that I started attending in town, maybe even 2006. And I helped found the Austin JavaScript meetup in 2009. And by the way, if you found a meetup, for those of you who might be interested, maybe you have some ecosystem that you're involved in and there's not yet a meetup, I highly recommend grabbing some people together. But just be forewarned that if you found a meetup, what that means is you will be speaking at that meetup every single time for at least 12 months. So that's exactly what happened. Me and another guy that helped start that, we traded back and forth doing all the talks for at least probably a year before we got other contributions. But my last talk at this meetup, which again, back in early 2018, I believe, I was talking about blockchain, about crypto. And I just want to give a big disclaimer that this talk may sound like I'm about to start talking about crypto, Web3, and I'm not talking about that at all, okay? Even though what I'm about to say is going to sound very related. In fact, rather than talking about Web3, the term that I'm using to describe these ideas that I'm going to share this evening, I call Web 2.5. So that's not just a funny way of differentiating from Web3. I actually was working at a Web3 company when I coined that term a couple years back, working at a Web3 company, and became convinced that the world was not ready for anything like Web3 because Web 2 was nowhere, there was no bridge. And what we needed to do was actually rethink the way that we build the web. And that's when I called it Web 2.5. Now that might sound like it's the precursor to Web 3. I have no idea if that will be true, but I am quite convinced that we will never get to Web 3 if we don't first do something like Web 2.5, okay? So I'm not in any way, shape, or form saying, hey, everybody go out and put all of your life savings into a cryptocurrency, nothing like that. There are some great things that I think the movement behind decentralization and blockchains, smart contracts, things like that. I think there are some actually really important ideas in there, But like I said, I don't think we're ready for that yet. So the things that I'm going to be focusing on do have a relation undercurrent, but I am not at all trying to endorse them. Also, we're at a bleeding edge web talk, and some of you may be wondering what, if I'll give you a link to my slides. This talk is so bleeding edge that there are no slides yet. We're going to create them together while I give this talk. So the first thing I want to say is if you're following along here in person, those of you that are online, you won't be able to do this, otherwise you'll disconnect. But if you're following along here and you have a device out, and most of you don't, but if you have a device, I would actually encourage you to open up whatever device is in front of you right now and turn off the Wi-Fi. And you'll understand as I go through this talk why I'm suggesting that. But I was going to turn off the Wi-Fi until I found out that I was going to have to present through Zoom. So you're going to have to trust me that if I were turning off the Wi-Fi, everything that I'm doing would still work. But unfortunately, if I did that, the people online and the recording would lose it. So that's just one of those little gotchas of tech, is that I did not prepare for having to present over Zoom. But anyway, I encourage you, turn off the Wi-Fi on your device. Part of that is because I want us to be fully present, talking together. And part of it is because that's actually some of the message behind my talk tonight. So the first thing that I want to ask, if we're talking about the web, is what is this client-server model, okay? And specifically, we should ask ourselves, what is the client and what is the server? And I'm going to give some very basic, high-level idea behind this, and you may or may not agree with that idea. But what is the client? What would that mean if I were talking about the client? Well, I'm going to very simply define the client as the thing that you hold in your hand and integrate and interact with, whether it's your phone, your tablet, your laptop, whatever. The device that you actually directly put your interaction and input into, I'm going to call that the client. So then what is the server? If that's the client, then what is the server? Well, it's everything that's not the client, if we're being really honest, okay? So there are a whole lot of things that might go under this heading. Let's talk about some of that. But I'm basically saying that collectively, all of those devices together play the role of server, and I'm using air quotes here on purpose. They all play the role of server. And what distinguishes them is that they are all elevated with capabilities and privileges that are directly involved with providing you that website experience or that application experience. And those are elevated privileges as considered with a client. The client doesn't have the same privileges to turn around and provide that application to someone else. Otherwise, that wouldn't be a client anymore. It would be a server, right? So that's the distinction I'm making. Whether you're simply consuming that experience and interacting with that experience, or whether you are involved in some way with providing that experience to another client. That's the difference between the client and the server. So there's a whole lot of things that go underneath that heading. Yes, we have edge. Everybody knows about edge servers, right? And those were all the hype there for a couple of years. We have CDNs. We have the entirety of the cloud. We have AWS Lambdas. We have Cloudflare workers and durable objects, GraphQL endpoints, databases. All of it is the server, okay? And from the perspective of my discussion, I don't care how many different physical machines or virtual machines that might be spread across. I actually don't care where on the internet it is, as long as it's not actually physically on my device, it becomes the server. So what about that term serverless? I'm sure you all have heard that term thrown around for years. We basically pretended that the word server was just about whether or not, who had the administrative responsibility? Whose job was it to make sure that that thing kept running? So when we stopped wanting to have that responsibility and started using somebody else's something and we treated it as a black box, then we got to say that's serverless because there's no more servers because I don't have to manage anything. We just integrate with all these other great providers. Well, what is it then? What is that thing? If it's not a server, if this is serverless, then what is it? It's a magical unicorn fart? I don't know what it is, but it's not a client. We know that, right? It's not a client. And in my way of thinking about things, if it's not a client, then it still must be a server. The serverless nonsense term, let's not get distracted too much by that. Most importantly, all of the things that fall under that heading of server, serverless included, they all have the same pros and cons of any other server, at least from the perspective of this talk. So let's talk about pros and cons, wins and evils. We all know that the server in the server client model, especially as we're talking about the web, that is the de facto standard. In fact, most everyone in this room probably cannot imagine or even remember, was not maybe even alive. Some of you are young enough, maybe you weren't even alive, for when there was an internet that did not involve something that we would call a server. There was a day way, way back. I remember some of those earliest days. But all the inertia and momentum is around what we currently think of in this server client model. There are these things that we call servers, and they're big, giant machines out there somewhere in the cloud. They're not on our device. And then we have this internet connection, this pipe that runs over to our device, and it sends us all those bytes, and those bytes magically become an experience that we can interact with. So the first big win of the server is that if you're choosing to build an application and you think, should I use server client as my model? Of course, all the momentum and inertia is behind you on that. All of the software that you will get, all of the software that you might find in open source, all the software that you may pay for as a service, all of the services that are out there. In fact, almost the entirety of the talent pool that you might hire from, all the content, the tutorials that you may access, and even all the infrastructure that you're likely to integrate with, it's all based around the server client model. So that's a huge win. Just stick with what works and what has been working for now 25, almost 30 years. Another win for the servers is that when you have data loss, then it's not tied to a physical device, right? If I were to have only data on my phone, for example, and then I was an idiot and lost my phone, I would lose all of my data if that was the only copy of it. That's pretty obvious. But when we use the server client model, we think about our data being out there in that server, and we essentially believe that that data is kind of permanent. Like it'll never go away because those administrators are taking care of making as many copies and backups as they need to ensure that I will never lose that data. I'll always have access to that data as long as I have an internet connection, right? So we don't have to worry too much when we have data loss. We don't have to worry nearly as much about that problem when we use the server client model. Now, another big win for the server is that it provides the easiest, and I'll use quotes here, the easiest form of all the following things: identity, centralized federated identity, things like using a Google login, GitHub, Meta, et cetera, right? Many of you probably work on websites that just have a Google login or a GitHub login or something like that, and then you don't need to worry about any of that stuff. You've just offloaded that problem onto the great folks at one of those companies that provide those centralized identity and authentication and authorization types of services. You also might be aware that there is a synchronization problem, right? Let's say that you build a website or web application that provides a collaborative document, something like a Google Docs or something like a drawing, like TL Draw is kind of a really cool app, if any of you have seen that, where you can just collaboratively draw together like you have a shared whiteboard, and there's many of those types of examples out there. So when two different people are contributing to the same document, if you will, obviously it's possible that one of them might do something that might overwrite the actions of the other person, and there's kind of a race condition where two operations might arrive at the centralized server location, and then it's got to figure out, what do I do with this? One of them said to double it, and one of them said to delete it. What do I do with that information? Well, that whole concept of what do I do with conflicting information is dealt with through a series of different techniques, but broadly we can refer to that as CRDT, okay? So that's the next one I'll put here is CRDT. This stands for Conflict Resolution Data Types. So CRDT is actually, it sounds like it's a library, and there are many of those, but it's actually a really complex set of techniques, and they can be very, very simple, like last one wins, right? We have two actions that show up, and one of them says double it and one of them says delete it, and I'll just take the last one, or first, right? That's a strategy like that, simple like that, is a CRDT. It's not a particularly useful one in most cases, but it's a CRDT. And then there's much, much more complex ones, which are merging things. And you've probably seen on Google Docs, if you have two different people that start to type on the same word and somebody adds a letter and somebody else deletes another letter, even right within the same word, it seems to almost magically figure out what the intent was there, and the word doesn't end up all mangled up with doubled up letters or things like that. And that's because they're using a really sophisticated set of synchronization strategies behind the scenes that we would call the CRDT. All right, so I meant to put in identity. Since I can just edit this, I'm going to put in identity here. So CRDT, that's another one of those wins. Sharing. Anytime that you produce some information and you want to share it with other people, think social media services, for example, something like X, formerly Twitter, or Facebook, or something like that. You produce some comment and you want to share that with other people. The most obvious way for everybody else to get that thing is for it to go up up to the hub, right? If we think about a spoke and hub architecture, that's essentially what server client is. The hub being the server, the set of servers that represent that application's centralized control. And then all of the spokes on that wheel are all the different clients. So if you send something and you want everybody else to see it, you send it up to the server, up to the central hub, and then it broadcasts it out to everyone else. So that's the most obvious and easy way for you to share information with other people, especially people that you're not physically local with. So we've got sharing, another big win for the server. And I guess maybe the last big category of this would be discovery, right? You and I don't have a connection in any way, shape, or form. How are we going to find out about each other, especially, again, if we're not physically local to each other? How do we even find out that I have an account and you have an account and we should connect and talk? Well, there's going to need to be some sort of intermediary for that. The most obvious intermediary is the server, right? Whatever that big amorphous blob in the cloud is. So all of these are wins for servers, right? All of these are big wins for servers. But there are definitely some evils, and this is kind of the main crux of this talk. So what are the evils of servers? What are server evils? Well, some of these are going to be pretty obvious to you, and some of them you maybe haven't stopped to think about. The first one that I'll point out is that all of the clients that need to be updated, they need to get updates. Updates not only to the application assets. For example, you've got new code, you fix a bug, you introduce a new image, update the CSS styling. Those updates need to go down, but also any data that client is consuming, that data needs to come and it needs to be incorporated into the experience that somebody has on their phone, their tablet, their laptop. So client updates for the application assets or the data from the server, they're treated in this web model, this client server model, as just in time. You've probably heard that term before, JIT, just in time. It's usually used in compilation, but we can broaden the perspective there and say that essentially we have a just in time model for the web, which means that it doesn't matter what my previous version of any of those assets or data were. When I go to visit that website, that web application experience, I'm going to request the latest of all of that stuff, and it's going to go and try to get that as quickly as possible and update it right as I'm waiting to experience the app. That's a just-in-time model. Unfortunately, we know that the user psychology tells us that you have about 50 to 100 milliseconds maximum between when a user does something and when they can perceive that there's been some sort of delay. And that's a pretty small window because users are generally expecting instantaneous response from their application software. And when they click something, for example, navigating to your web application, opening it from an icon on the homepage of their device, for example, they're generally expecting it to be ready pretty darn quick. So the ultimate goal would be for it to be ready within 50 to 100 milliseconds. And the vast majority, 99 point with a whole bunch of nines after it, % of the web is not fortunate enough to either have powerful enough hardware or, more importantly, powerful enough internet connection for that to happen. We're creating dozens and dozens of megabytes of assets, and you're not going to transfer dozens of megabytes of assets down to their device, plus several megabytes of new data for them to get updated information and have all of that happen with 10 or 15 or 25 milliseconds to give yourself enough time to just render everything, right? Because we know that client rendering does take time as well. That's why we have frameworks that try to make that stuff faster. The fact of the matter is that because we're not hardly ever going to hit that sub 100 millisecond threshold, we have a model called just in time, but it's not actually just in time because it's not in time. The user expected it instantaneously and they didn't get it. So we have a whole series, a panoply of interconnected web platform features for managing temporary copies of these assets on user devices, both the assets and the data, and they're extremely complicated to get actually correct. I don't know if any of you have ever worked with that part of the web platform, but trying to get your caching headers to work and make sure that this one doesn't get messed up by some proxy or some router and all these weird, there's all these different rules and it's super complex. If you actually go and look at the specification for how those headers work, it's dozens of pages long, if you're wondering just how complex this actually is. In fact, probably the only almost surefire way to ensure that all the caching is working according to the strategy that you really want, meaning that only the things that you want updated are updated and nothing unnecessary, but definitely the stuff you need updated is updated. Probably the only way to really do that is to actually write the code yourself, write a little server on the client in the form of a service worker. And I, by the way, highly recommend that all websites, all web applications, without exception, 100% no exception, you should have a service worker that was managing that stuff. Because the caching headers and all that other stuff, you've definitely got it wrong. And there's a suboptimal experience. In fact, for the vast majority of people, the experience that they're getting is that the client server web model is just reinstall on every visit, or almost every visit, okay? So what we're getting is reinstall on every visit. And I'm gonna put a sad face there because that sucks. We have to ask ourselves, who would reasonably tolerate that in any other circumstance other than the web? I mean, think of any other app that you have installed on your phone that at the moment that you went to open the app is when that app said, oops, sorry, I've got to download 100 megabytes. Please come back in 30 minutes, right? We would not tolerate that. In fact, we do not tolerate that in any other part of consumer software except on the web. We're drunk with this idea that we can have instant on the web. We can have this instant zero install sort of experience. But in fact, we're just forcing people to reinstall the entirety or most of that application over and over and over again. And by the way, this spawns a whole billions of dollars huge industry around performance optimization. The complexity around performance optimization, which by the way, I'm just going to throw out a few words. I could do hours and hours of talks just about this one little problem. But all of you know that we have had a web that's been full of spinners. You've probably heard terms like hydration, resumability. We've got React server components. We've got quick framework, optimistic UI, and a whole host of other concepts that are all adopted complexity. They are chosen complexity because we chose the client server model and we chose to convince the world that it can be an instant-on experience, which it really can't. We've invented all of this billions of dollars of industry and complexity on ourselves just so that we can try to pretend as if the web works that way. So I'll just put performance. I don't want to type all that stuff out, but I think you get the point, okay? There's a lot that we are forcing upon the users of the web experience. By the way, the server-client model, client-server model, fails in both offline experience when somebody has no internet, but worse, it fails even harder in intermittent connectivity. In those situations where you're sort of on and off, on and off. For example, you're on a train or a bus or some other public transport, or you're just walking around downtown and you're just occasionally getting signal and not getting signal. Anyone ever had the experience of intermittent connectivity on their device where things were like partially loading and failing and you just kept refreshing and refreshing, hoping to get one solid load of everything? You see, it didn't work that you could just refresh and it would get only what you needed. Every time you refreshed, it got all the whole damn thing over again, right? And so unless you got lucky and got just long enough that you were in a place with connectivity, you couldn't experience the web there. That's one of the deepest evils of the client-server model, is that it assumes persistent and guaranteed internet connectivity. And we in the privileged first world have a lot of that, no doubt. But the vast majority of the world does not. We're just building this web with this assumption that somebody, some rich billionaire will put a bunch of balloons in the air and we'll eventually have worldwide complete coverage of internet connectivity. It'll never happen. That I'm quite certain. We'll never have all of that problem fixed. But even if we were talking about offline or intermittent, there's even more evil. In fact, this is probably maybe the worst of all. There's no ownership of data. When our data is not ours by custody, when we do not physically possess the data, then it's not truly ours at all. As soon as we take a piece of data and send it up the pipe to a cloud server, it has stopped being our data. I don't care what their terms of service say, that it's yours and they'll keep it private and all that. That's nonsense. Once you do not physically possess the data, it's no longer your data. In fact, it really stops being a web of user-owned information, and the web has really just become a vast store of user-based, provider-owned data. It's about you, but it's not your data anymore. As soon as it leaves your device, it stops being yours. Here's a test you can ask yourself. Can you take that data that you just created or inputted into any web app with you when you leave that web app? Think about this. When was the last time that you were working with a web application in any shape or form of any name from any vendor where they made it super easy for you to just take that data and go somewhere else? Maybe to an offline scenario, maybe to a competitor's application. Can you take that data with you? The answer for the vast majority of us and for the vast majority of our experiences is absolutely not. You don't own that data, so of course you don't get to take it with you. They have a vested interest in making it really hard for you to take that data with you because they want to keep you, they want to gatekeep you from leaving, because that's the only way they can make money is if they own your data. That's it. If you owned your data, what are you paying them for? So they have to own your data so that they keep you captive. I lied. Actually, this isn't the worst of the evils. The loss of privacy is probably the worst of all the client-server evils. Tracking, right? How many people love it? You don't get them nearly as much here in the US, but especially if you travel abroad like to Europe, how many people love getting a cookie banner on every single website? Isn't that awesome? Right? Because we've got laws that are trying to catch up to technology. They're trying to say, well, if we're going to require that this is the way that technology works, that these businesses insist that the only way for them to make money is to track every single swipe and click and letter that we type on all of our devices, if that's what we're just going to assume, well, then we're going to have these kind of mostly pointless laws come along and say, well, at least you have the right to ask for that stuff to be deleted. That's really what all that stuff is about. You've got all this data that's going to be created about you, not by you, but about you. And maybe if you are persistent enough in asking, somebody will delete that data if you don't want it out. We have no guarantee, no expectation whatsoever that we can have any sort of privacy in the modern web. Yeah, you think you're getting privacy because you browse the web in incognito mode? No. That's just a feature that's presented to you as if make them feel a little bit better. Make them feel like it's a little bit more private. It's not private at all. Every piece of data that you enter into there is being sucked up into the exact same cloud that all the stuff in your regular mode browser did. And I'm quite certain that they can correlate your behavior in your logged in browser session with the behavior in your incognito mode session. Same IP address, right? Unless you're going to lots and lots of trouble to make sure that you air gap the experience of how you browse in incognito mode, it's almost certainly just theater. You see, what all of this boils down to actually, and many of you work for businesses and you're looking for maybe an argument to take away from this talk. All of the things that I've said up to this point, they're almost like moral or ethical arguments, evils that are, somebody can make a case that, hey, that's better for us. We make more money that way. But here's one that nobody can make a case for at your business, which is the millions, billions, trillions of dollar industry of all these rent-seeking landlords that have inserted themselves into the equation under the guise of ease of use, right? All of those wins that we talked about, they're like, hey, we're going to make this super easy for you to have. You just click a button in our little dashboard and we'll spin up those little Lambda functions for you and these durable objects, and you don't need to worry about it, right? It just costs you pennies, no big deal. Those pennies become dollars, which become hundreds, thousands, tens of thousands of dollars. Not at all unheard of for modest, moderately sized businesses to have tens or hundreds of thousands of dollars a month that they're paying to these huge rent-seeking landlords. They're value extractors. Yeah, they are providing you a service that somebody at your company has been convinced that you should write a check for. But none of that existed 10, 15, 20 years ago, and the web was every bit as capable as it is today. Yeah, we have more cool, shiny features, but the web, everything that's built on the web today could have been built on the web 20 years ago. But what's different now is that businesses are now having to pay billions and trillions of dollars to these rent-seeking landlords. All of the cloud providers, the huge company. All of these are the evils that I think about when I think about that server, that collection of all those devices. I'll just summarize it with that. All right, so how could we possibly imagine a web experience that would not involve this big server, both with its wins, but also with its evils, with its losses? How could we imagine anything that could possibly replace that model? Well, again, telling a little bit of a story back in the very, very early days, back in the late 80s and early 90s, some of my first experiences with computing devices that connected to other computers than my own, that were networked out to what we would eventually start calling the internet. And we had bulletin board systems. I don't know if anybody in here even knows what I'm talking about, but BBSs, right? And you didn't have like an always on internet connection. You literally had to dial in with one of those dial-up modems that made all the funny noises that have become kind of a punchline in, media and jokes and movies and things like that. But that was reality. That's how you connected out to others, is that you dialed into somebody else's machine through a modem, made a connection. And what you had on your device, which is what you were experiencing the web with, but you also had information on your device that other people could connect directly to and see that information. You could post up a message, and that message resided on the same device that you were also reading with. So the server and the client were truly one device. And what you had in that early days of the internet was just a whole bunch of those client servers all in one single device. And they had a mesh of connections. There were lots of different ways that you found out about who was running a bulletin board for your favorite, online game or something like that. But back in the early days, the web was inherently decentralized. It's just that people came along and said we can make a whole lot more money off the web if we centralize. Not that there was something inherently that the web needed it to be centralized. Certainly things, as I said, certainly some things are easier to do when you centralize. But none of those things are impossible to do without centralization. So this is the part of the talk where you start thinking, oh, he's going to start telling us all about Web3 and crypto and all that stuff, and I'm not. Decentralization is the web's root. It's not a new invention that Web3 came up with. I'm old school and I'm saying we got too far afield from where the web was actually in its best days. We got drunk on all of these other things that we've put on top of it. So how might we imagine, I'm not suggesting we're going to go back to the bulletin board systems, but how might we imagine something that all of us tangibly already experience, but have that still be inherently web? Well, I'm going to suggest that the internet needs to become the web of installed experiences. Just like the apps that you install from the Apple App Store or the Google Play Store, those are bundles of assets and in some cases data that are shipped to your device ahead of time, not on demand, not in time every time you try to open it up. And those apps are constantly updating themselves in the background, aren't they? They're updating themselves in the background so that when you go to open up the app, you already have the latest behavior and all the latest data that is necessary, and you get virtually an instant on experience. You almost never open up an app and then see a spinner unless that app is built on the client server model, right? It's probably a React Native app that's really just talking to a server somewhere. But real native apps that take this seriously know that users want to click the button and immediately start looking at the information in their bank account, for example. And I don't want to see a whole bunch of spinners and wait for all kinds of, things to update themselves little by little. Oh, and by the way, let's talk about bank accounts for a moment. That's one of those things where people think, if I open up my bank account app, I absolutely have to have the latest up to the millisecond information about my bank, right? No, not inherently. There are plenty of times when I open up my bank account and all I want to do on my bank account app is look at a transaction from a couple of weeks ago, something that I've long since downloaded. Yes, it might be nice to also see some of the updated things like my current balance, but I would like to open up my bank app and look at one of those old transactions, even if I have no internet connection. When was the last time you opened up a bank app that let you do that? Even if they had that data, they're not going to let you see it right away. They're going to force you to have an internet connection to connect in and all of that stuff. So what I'm suggesting here is that apps have a bunch of wins. What are the wins of apps? So first of all, instant start. Virtually instant start. We don't need to go to some other device to ask for some information because we already got that information in the background. We updated that information, both the assets and the data, and we have it there. So the only thing that's limiting how quickly it starts is the CPU of our device, which we can also do a lot about. We can try to not make things so complex that it takes forever to render. So the updates in the background are critical. By the way, the web is able to do, I don't know how I underlined. The web is able to do, there is a spec for background updates. It's only in Chrome, which sucks. Because all the best things of the web only show up in one of the browsers, whether it's Chrome or Firefox or somebody. The best parts of the web never seem to land in all the browsers until years and years and years later. We have periodic background updates, which is a spec that I use in my apps. When I build web apps, I use this periodic background update. And what it says is it registers with the browser whenever they install it, not just when they visit a website, but when somebody comes to it and says, I want to have this web app installed, a so-called progressive web app, I want to have it installed on my device. I register with the browser on that device to say, approximately every 12 to 24 hours, will you please just send a ping home to the server to see if there's any updated assets or any updated data? And if so, go ahead and update that stuff in the background via a service worker. So that the next time somebody opens up my app, they've got the latest of my assets and the latest of the data that they need. Periodic background sync. It's a fantastic idea. It would bring the web a whole lot closer to what we can get out of native apps, constantly updating themselves in the background. Unfortunately, we're a little bit lacking because some of the browsers think that that's going to be a bad feature. I really can't think of the downsides of updating things in the background so that users have less delay. I think we would eliminate a whole bunch of the evils that I just described. Apps also have better OS integrations. Okay, we know this. Inherently, we know the differences between a web app experience and one of those native app experiences, whether it shows up in our add and remove programs on our Windows desktop, or whether it has a context menu that works properly or whatever. There's all kinds of, whether the icon can show a badge on it with a number of the text update in it, all kinds of things that native apps have. The web is just sort of begging, like, at the edge of the table, begging for some food scraps, hoping to catch up to these things. Apps have better OS integration than websites do. And by the way, one of the most important OS integrations that full apps have capabilities of is actual durable storage. This was mentioned a little bit earlier in the intro talk here. All of the storage that we have available to us through the web platform, whether that is local storage, whether it's IndexedDB, a variety of other types of storage capabilities that we have, all of it is what we would call volatile storage, meaning that somebody other than your application can decide, whoop, I just deleted all that information. So if you start storing really important data for that user, and maybe the only copy of that data in the volatile storage, you're asking for that user to open up their app someday and all the data's gone. That sucks. So volatile storage is a huge barrier of us being able to rely only on web platform technologies. Now, there are, again, just like every other problem I'm discussing, there are standards that are trying to catch up, right? We have the file system API. That's a spec that's landed in both Chrome and Firefox. It's not yet in WebKit, hoping someday maybe, right? But at least it made it in two of the three big browsers, so that's better than Chrome only. And there's all kinds of other device capabilities that we have access to when we have a true native layer involved in the discussion. For example, we're going to talk about this in just a minute. We might want to have actual low-level UDP internet connection. Now, there's been discussion for years about whether or not the web platform should expose a UDP network connection layer, kind of like you can create UDP sockets in Node or something like that, those of you that have done that. There have been discussions about we need that kind of stuff directly inside of the web platform, right? And then there's all kinds of reasons why people say, well, the web is, it's going to get abused. We can't put those APIs in there. But device capabilities, like having the ability to directly communicate, did I spell that correctly? Directly communicate over network sockets, or as I said, the storage capabilities. And by the way, all these apps that I'm talking about, they do not have to be solely written in Java for Android or Swift or Objective-C. There's a whole bunch of ways that these apps that can take advantage of these better capabilities on the device can still be mostly or even sometimes entirely built with web technology. For example, we have PWAs, progressive web apps. Those are based around service workers. And by the way, there's a tool out there called Bubble Wrap. If you haven't seen that, you should go look that up. Bubble Wrap. It's a tool that takes your PWA, your service worker-based PWA, that already is installable, right? Because if somebody shows up to that website, gets the little pop-up that says, do you want to install it? That already works on almost all devices, including on iOS devices. And there's a little bit of finickiness there, but it works pretty well on almost all those devices, even iOS. But what Bubble Wrap does is it takes all of that and it figures out the best way to create a web view-ish type experience of that exact same set of resources inside of a native app wrapper. So it's a free tool. They literally have a website that you can go to and just, it's called, I forget the name of the URL of this website, but you can literally just pump in the URL of your progressive web app and they'll spit out an Android APK and something for iOS, whatever the iOS package binary is called or whatever. And you can just upload those directly to the App Store with virtually no changes, no code changes at all, just a little bit of configuration. You can take one of your PWAs and put it in an app store. And there's lots of other ways to put your web-based technology in app stores. There's things like Tauri, T-A-U-R-I, Socket Supply, it's a company I used to work for, Electron, you've heard of, I'm sure, Ionic, NativeScript, Apache Cordova, React Native, surely all of you know about that. None of those require you to learn native OS, although learning native OS to augment them is certainly a good idea. But you can get started with all of those and take web-based applications and create a native application around it. And that gives you the ability to start tapping in the better operating system capabilities like better storage, better networking, things like that. So all of these are reasons why apps as an experience, not just apps as a technology, but apps as an experience are preferable. They beat out some of those evils of the server. Now, some of you are going to say, well, wait a minute. There's a whole bunch of problems. So let's talk about the evils of apps, right? Because I'm glossing over stuff. I'm saying, oh, it's all great. But we do need to give a nod that there are some downsides here. First of all, some people really care about how cluttered up their device screens get. If every single time you go to McDonald's or Sonic or any other kind of restaurant or store, everybody wants you to download their app, and all of a sudden you got like 600 different apps cluttering up your device, right? So the cluttering of your device with apps is a problem. Device screen. That's a problem. Now that's a problem that users have to decide one of a variety of different ways to solve. Some of them solve that by simply not downloading apps, and there's nothing that we can really do about that. But some of them solve it through organizing things with folders. Operating systems are starting to come out with interesting layers and views and other ways to categorize our apps. And so that problem is actually, I would argue, less a developer problem and more the vendor of these operating systems, they need to allow people better capabilities for organizing hundreds or even thousands of apps. And they will, they'll catch up to that. They're already starting to do so. But it is certainly an evil that some people might be a little bit frustrated by having to have that many apps installed on their devices. Also, there's a perception that native apps track users even more than web apps and websites do, right? So is tracking even worse with an app? Well, certainly because an app has more capabilities on your device, it has its ability to get its fingers into more things. For example, a web app may never expose the details of my contact list to any website that even wanted to try to ask for it. There's no API for that. But as soon as I have a native app, it might start trying to access the contact list on my device. I use LinkedIn. Some of you know I have a presence on LinkedIn. I don't use the LinkedIn native app on my device because the LinkedIn native app asks for contact address book access. I don't want to give it that. So there's certainly a potential for apps to ask for more things. Now, they're probably going to have to disclose all of that in some dialogue that users are never going to read. But there is a potential that native apps will do even more tracking because the web has done a pretty good job of putting up some barriers. Now, let me take just a little side note here. For the barriers that the web has put up, the privacy, the sandbox that the web is. This is vaunted as one of the best parts of the web, is that the people that have built the web have had this really keen eye to look at all of these things that if we, for example, notifications, right? How many people love that every single website that you go to pops up a little dialogue that says, do you want to allow notifications, right? That can be really frustrating to be getting those prompts all the time. Another of my favorite examples, the battery API. This is an API that a website would be able to just query how much battery usage is there and even track it a little bit over time. For example, just to try to shut down some of its more complex processing tasks if it saw that their battery level was too low or something. Great idea for an API, but it turns out it was a vector for people to be tracked. So they had to completely eliminate that API. The Chrome had it for a while and then they took it out. Firefox said, nope, there's a privacy problem there, right? We can't allow that. So most of the really good ideas where we would like to take native capabilities and expose them to websites, to the web platform, most of those have legitimate concerns of why we shut these things down, legitimate reasons why we don't want to allow, those things to have that kind of access. But I'll tell you that one of the real problems that we have, and this is maybe one of my biggest complaints against the entire web standards community, is that I think there should be a massive difference between what the web platform exposes to a website, where I've just driven by it. I might have clicked a link and it was accidentally not what I wanted to go to. That's a drive-by experience, and I in no way, shape, or form have expressed that I trust that experience. That thing should be really locked down. In fact, there's a whole bunch of stuff that websites probably ought not to be able to do. We ought to lock that experience down even more than it already is. But there's also a whole bunch, there's a huge difference. If I've gone to a website 3, 4, 5 times, if I've gone back to that website, if I've created an account on that website, if I clicked an install button and put that thing on the home screen of my device, I have now said, guess what? I like this application. I trust this application, and I ought to have full access to it just as if it had been a native app. So one of the big problems is that we have this conflation, I'll call it, between a website experience and an installed web app experience. An installed web app experience is a user saying, I trust this thing. We don't need to pop up a whole bunch of more permission boxes any more than we would need to for native apps. We ought to expose all those things, including things like a battery API. Once I've decided I want to install this web experience as an application persistent on my device. That's one of the evils here is that, and it's not really in our control, it's web standards. They refuse to look at it from this perspective, and I've tried for years to understand why, and I can't figure out why. There are some things that they've done, but they usually only distinguish between whether the feature can be available on HTTP or HTTPS only. That's like the only thing that they put into the spec. They don't seem to distinguish between it's been installed or not. And that's not difficult for them to do. They could put all of these features gated behind did the user install the thing? Or even did the user install it and then open it a couple of times? We definitely have enough of a heuristic there that if I've installed the thing and I'm using it on a daily basis, guess what? I trust it. Please give it access to all the APIs so that I can have a full fidelity experience in that app, just like I would with something built with Java or Objective-C. All right. Another problem with apps, one of the other evils of apps, is that inherently this still requires the internet, right? Most of the apps that we use, like for example, the bank apps, most of those apps still connect to the internet right before they show you anything. I mean, you might get a little app shell with a nice little like logo and a loading screen or something, so it instant started in that way. But all the useful, usable information in your app is still gated behind, can I connect to the internet? Now, one of the reasons why, for example, a bank is trying to do that is because they don't want to trust the physical security of your device. So they want to double check the security on their server. They want to make sure that you've entered in some email and password and some other two-factor authentication and maybe a third and fourth factor of authentication. Talk about authentication more in just a minute, but that's one of the reasons why they're doing that. But I would argue that if my device has been compromised, the least thing that I'm worried about is whether they know any of my username or password. If my device unlocked falls into a hacker's hands, it doesn't matter how good of a password I picked for my bank account. They're going to get access to that information in some way, shape, or form, either through a login session or something stored somewhere. They're going to have access, or they had a key logger running on my device. If you lose physical security of your device, all bets are off. So this concern that we have about, well, we'll put up this last little barrier to them, which is a hard to guess password. It's nonsense. All right, so we still require the internet under the old way of thinking about apps, which is really just kind of this thin little shell that still connects up to the big server cloud. And I guess the last thing that we could say is that it is still a bit harder to discover. Discovery can still be a little bit harder when we're dealing with apps that are in an app store, because the search functions on those apps have been gamed to hell, even more than search engines have been gamed to hell. And so there's a question that people have is like, well, how will anybody find my app if I stick it only in an app store? What if there's not a Google search someday? I got news for you. Google search is probably going to go away anyway because of AI. So we need to start coming up with different ways of thinking about how people are going to discover our stuff other than through SEO. I think the days of SEO are a bit numbered. Or we'll be gaming through AI prompts or something else like that. But it's not going to be traditional SEO the way that we think about it. So yeah, it's a little bit harder to discover. That's definitely one of the downsides of apps. But let's talk about, for the rest of this talk, let's talk about some ways that we could improve the way we think about apps. Now, some of you, in fact, probably the majority of you, are still thinking there's no way the web is ever going to move to an app experience. All the problems he just listed out, those are insurmountable problems. And what I'm going to try to point to is that there is a movement that has really started to gain steam that I think is going to solve most, if not all, of these problems. And I really do think that that Web 2.5 that I described earlier is pointing to what we're going to see the web become. So there's a movement called local first web development. It's actually local first software development, but it's certainly pretty inherently related to the web. First of all, let me dispel one of the myths around local first. A lot of people think that this is just offline. How many of you know that term, offline first? Some of you nodding. Most of you are too tired to raise your hands. That's okay. Offline first, the idea behind that goes back 10, 15 years. The idea behind that was start by assuming that an app should behave or should be able to open up. It should still exist on a device, even if there's no internet connection or if the internet connection is bad. We've talked about that. That's an important thing. But local first is a much bigger idea than simply offline first. Certainly offline ability is important, but there's a consultancy group called Ink and Switch. Back in 2018, 2019, they coined this term local first. They put out a blog post, and I'm going to show you a QR code here. So let me pop up this. I'm going to be doing several QR codes for the following links. So if you want to scan QR codes to get these blog post links. By the way, at the end, I'll give you another way to get it if you don't want to do QR code scanning, but there's a QR code to the Ink and Switch Local First Manifesto, effectively, the big post that they put out, which is actually a paper they wrote for ACM, and then they posted it as a blog post. But just to summarize what Ink and Switch said about Local First and what this movement has become, it's founded on these 7 principles. No spinners, your work at your fingertips. I already love it. Your work is not trapped on one device. Number 3, the network is optional. That does not mean that there is no network. It just means that if the network is gone, everything should behave the same. Okay? That's important. Not that it degrades or all it does is show a little shell that says offline and doesn't give you anything. There should still be a meaningful experience even if there's no internet. So the network must be optional. Seamless collaboration with your colleagues. That speaks to, in another term, peer-to-peer, right? Your ability to talk to your peers, your colleagues, other devices, without necessarily having the internet. The long now, I won't go too far into that, but their blog post describes a lot of these in much more detail. Security and privacy by default. And finally, you retain ultimate ownership and control of your data. So you can see why those principles underlie a lot of what I've been saying today. The local first movement is where I believe the web needs to move. And I think we would do ourselves a big favor if we started asking ourselves, how can I turn my app experiences into that? Okay, so I'll put down Ink, Switch, and the 7 principles. Definitely go and read that post and read up more on the principles behind it. There are some extensions that I would propose to local first. I say they're extensions because I'm not trying to co-opt local first or try to redefine it, but I think it can be bigger in some ways than what they originally defined. And they seem to be pretty intent on keeping the focus only on their original 7 principles. So I'm just going to call these extensions of local first. One extension that I'll talk about is local only. This is actually a big one for me. A couple of years back, you might remember that here in the United States, the Supreme Court came out with a decision that eliminated the guaranteed right to abortion for women, those with uteruses, all of that, right? Well, I have people in my life that directly impacts, and I think it matters. And one of the things around that conversation that was being discussed was, well, applications that track someone's medical health information might be used against them. If all that data is going up into the cloud and they don't control that data, it could be used against them under those new laws that they were foreseeing going up. And that wasn't just a thought, it actually happened. There were people that were prosecuted based upon the data that was captured off their device by law enforcement. So it really prompted me to start thinking, there's actually a whole bunch of things that I do in apps, data that I put into my apps, that I don't need to ever leave my device. There's no reason whatsoever why that data ever needs to go anywhere else other than my device. And actually, I'll broaden my device to actually what I call a local ring. Anybody remember the term web ring from way back in the day? I've co-opted ring to refer to local ring. That's your local cloud, if you will, of your devices. Your watch, your phone, your laptop, your tablet. All of those are one connected unit in what I'm viewing. So I might not want that data to go outside of my local ring, but I certainly wouldn't mind for that data to be shared among all of my own privately trusted devices. I'd like it to be on my phone and my laptop. Things like note-taking, right? Why do I need a cloud-connected service to take notes? If I have an app that I can take notes on and it seamlessly connects with all of my other devices without any internet, why do I need the internet? Health tracking, huge area. Basically, almost all of my health data, I don't want to leave my devices. I do want to track it, I just don't want it to go anywhere else because I don't trust what governments and people can do. And wherever you are on the political spectrum, I think distrust of either big government or big software is a pretty universal feeling in 2024. So if we just stopped giving them a whole series of that data, in fact, I think maybe a big chunk of the data that's going out doesn't ever need to leave the devices where it's being created first. So I call this local only development. Now, the local first folks, they say, well, that doesn't really count as local first because they want to allow there to be servers in the mix. But I'm suggesting, at least from my perspective, it's an extension or it's a subset that says you can build with all those same principles, and you can say, by the way, the data that's being stored on this device may never leave the device, and that's entirely okay. You might design it that way. Or you might design it where the only time that data ever leaves the device is when somebody manually goes and says, I want this data to be sent to somebody else. It doesn't automatically send any data at all. That's what I would call a local only app. Another extension, another term I coined here first. Okay, there's a whole other set of apps where the information that's being exchanged is going between me and you. And the only reason we have a server right now is because we haven't come up with any other architecture that can get the data from my device to your device if we're not local to each other. But there have been solutions that have been tried and worked on for this for many, many years. Peer-to-peer communications. Some of you have heard of WebRTC. Anybody heard that? That's a web API that allows two devices to create a direct connection with each other, even punching holes through routers and things like that. Direct connection with each other and share audio, video, and even data streams, right? There's one downside to WebRTC, which is that to get introduced, the two have to talk through a server. There's no zero server signaling, at least there's been experiments, but there's no production-ready zero server signaling for WebRTC. What if we could come up with a zero server signaling capability for WebRTC and then use the great WebRTC APIs plus all the great libraries and frameworks that are built on top of it, and automatically our websites could start talking directly to other instances of that web app on people's devices with no servers involved whatsoever. I don't necessarily mean no internet, but I do mean no centralized hubs where all of that data is flowing through. And if there's no centralized hubs, then all of those evils I talked about being tracked and hackers wanting to try to get into my data and steal it and all of that stuff, none of that, all that completely goes away because it's just my device and your device and the data goes directly between us. So one of the ways that this can be done, one of the ways that you can do peer-to-peer communications is through something like WebRTC. We've got to work on how to get zero server signaling, and there are ways that this is being worked on. There are quite a few players in this space, by the way, in this local first space. They're tackling different parts of this, whether it's the synchronization, the CRDT parts of it, whether it's the communication parts and all kinds of other things that people are going after. So I'll just name a few of these. You guys can go and y'all can go and check some of these out. We've got Electric SQL, we've got TinyBase, Replicache, PowerSync, DXOS, AutoMerge, and literally dozens and dozens of others. Now, some of you might be wondering, well, this sounds like a totally niche hobby idea. Is any big app with any name and reputation running with these ideas? And there are multiple ones, but one that I'm going to name that probably many of you have heard of is Linear. Linear put out a blog post where they said we built the whole Linear app experience. They rebuilt it actually, and we rebuilt the whole thing from scratch to adhere to the principles of local first. So if you've ever worked with Linear, you've worked with a local first app, and you've worked with a first-class quality local first app. It's not some hobbyist idea, okay? Big company, big money behind it. And all those other players that I talked about, there's big money being invested. So we do have lots of players. I'll just type out some of those like Electric SQL, a few others, TinyBase. I'll type out Linear, okay? By the way, there's a talk that one of the founders from Ink and Switch did on how can we, and again, from their perspective, they still accept the idea that there will be servers. So they haven't gone fully peer-to-peer the way I personally have, okay? Personally think local first needs to go fully peer-to-peer, but they're still thinking, and a lot of these players are still working in this idea of, well, we're still gonna have servers and we're gonna need to have some kind of synchronization between those server instances. But what do we do with the fact that we're going to violate one of our core principles of local first if we make ourselves required to have one of those servers involved to do all the synchronization, right? So that's a real problem. And there's a talk that Martin Kleppman put out. So I want to give another QR code here. This is actually a deep link to one part of his talk. but he talks about the end goal of local first synchronization. And the end goal of local first synchronization is actually to create a fully, like, actual real standard, not just something that somebody put on a random website, but an actual, like, IETF standard for data synchronization. They're pushing on this. They've got a draft of the spec already in process. They're going to try to get a full spec of this so that you can have essentially unlimited implementations of the same standard, which means you could have hundreds or thousands of different providers out there, all allowing this generalized unified synchronization through servers, completely secure, by the way, so that none of those synchronization servers would see anything, everything encrypted. And your data could be synchronized between using any of hundreds of those providers. So it's some really fascinating stuff. I really hope that we see more in that space. Now, I've mentioned a whole bunch of things, and you're probably wondering how you're going to possibly keep track of all of these. There is a website that I want to point you at. Let me find it here. This is the Local First Web Dev website. So that QR code, you should go to Local First Web Dev or just localfirstweb.dev. That's the URL. But you can scan that QR code. At the bottom, they have literally like over 100. It's like 150 different resource links to talks and companies and projects that are building in this local first space, attacking the problem from all different kinds of angles. So if you think that maybe local first is some small niche idea, the message that I'm trying to get across is this is going to be the next version of the web. I'm as convinced of that as I've ever been convinced in my 25-year career doing this. Some version of what we're doing in that community is going to be the next evolution of the web. There's just far too many reasons why everybody is going to win except the cloud providers. They're going to not win, but everybody else is going to win. And I know there's a lot of money behind cloud providers, but the companies that have already started to build in that direction, I think it's going to be hard to deny that inevitability. I don't know how long it'll take. I don't think it's like 6 months from now. I think it'll be years, but I do think it's an inevitability the web will move in that direction. One of the things that I don't think is being addressed enough in that space yet, there's lots of great resources and lots of people working on stuff, again, like CRDTs and things like that. But one thing that I don't think they're doing enough of, and this is kind of where I want to land for the rest of my talk here, I'm wrapping up, is identity. We think of identity as almost an easy to solve problem when we think about centralized architecture, right? Just use Google, just use the Meta, just use a GitHub login, whatever. But what does identity mean when we've completely decentralized everything, potentially having no servers whatsoever? Is there any way that we can still manage the you-ness of you as you go through all of these experiences and the uniqueness of you as you go through these experiences? Is there any way to still approach that without having to involve servers? So I want to pop up a little demo here. This demo happens to be hosted on a site for the startup that I've been helping to kind of bootstrap over the last few months. The startup is called Vela.ai. We're building a smart email client that helps you wrangle all the emails that come through and spend less time managing your emails. So if that sounds interesting, we're built on local first, and importantly, trying to do as much, if not all, of the AI analysis of your emails on device. Instead of slurping up all your data into the cloud, we're serious about this, and so we're trying to make that happen on your device to help you figure out what filters you need to create to manage and unsubscribe emails and all kinds of stuff. So check out Vela if you're interested. But this demo, not directly related to the Vela app, but we are building it as part of potentially something we'll have in our app soon. This is a local first auth demo. It's built around a library that I built, the link being right there. So let me just give you this QR code so that you can go to this same demo if you don't want to type in vela.ai/auth. This is vela.ai/auth. And I want you to try this demo yourself, by the way. So after you've gone to this URL and loaded it up, you can turn off your Wi-Fi and see that this demo will work with no internet whatsoever. I'll leave that up for just 1 second. If you missed the QR code, VELLA.ai/auth. Okay, so what this app is doing, again, I said it's using this WebAuthn local client library. That's a library that I built. It's using the WebAuthn API. This is a web platform feature. It's available in all the browsers, including on all your mobile devices. It's how you're able to do passkeys, like if you've got Touch ID or Face ID or something like that, and you log into some website. There aren't that many that are using it yet, but this API exists in the web, and it allows a website to grab a passkey, like your biometric login with your thumbprint or something, to log into a web application, okay? This is a built-in API that will interact with your native device. What I'm doing, however, and again, I would totally turn off my Wi-Fi to prove to you that it works offline, but you can prove it to yourself. Unfortunately, I would kill my Zoom if I did. But this works completely without any server whatsoever. Once it's loaded up here into this web browser, there's no server interaction. You can look at the developer tools and prove it. So I'm just going to register an account. And what that means is it's going to tell my operating system, hey, somebody's trying to do a passkey and we don't have one yet. Do you want to allow that creation? So what I'm being prompted here is, do I want to allow it? And because I'm using a Windows device, it's going to use my Face ID, if you will. It's Windows Hello is what it's called, but it's going to use my Face ID instead of a thumbprint, but it would prompt for a thumbprint if you were on that kind of it. So I'm going to say, yes, I want to allow that. And what that did was it created and it stored it securely on my device in a secure enclave on my device. It stores the creation of this identity. It creates a cryptographic piece of information that's used for encryption and decryption purposes. It stores that securely there. And this device will now allow me to log in with that same biometric. So if I were to come to this website and say, I want to log in, you'll notice that this little pop-up here is already saying, hey, we've got a passkey registered on this device. Do you want to use it? I don't even need to type anything. So it's this really nice streamlined autocomplete type of thing, or I could have typed it in. But if I type it in or I select it, now the operating system is saying, hey, do you want to log into that? And it's looking for my face, it sees my face, and I say, yes, I do want to go ahead and log into that. So now I am logged into this application. Again, no server whatsoever. But I prove that I'm the same person who registered this account because I'm using the exact same biometric ID to get in. And I'm using the security of my device that it's keeping all of that stuff safe. It's not even a browser feature, it's an operating system feature, just like on iOS where they store passkeys and things like that. So this little simple demo allows me to type some stuff like hello. Okay, and it's just saving that. And if I were to pop open, I'll save some time because I'm running a little long, but if I were to pop open the developer console, it actually encrypted that information in local storage on this device. So I'm going to log out of this device now. That stuff is still there, but it's encrypted, so nobody can get at it. And if I want access to my information again, like for example, if this was a bank app, I want to see all my previous bank transactions that have been encrypted on the device. I simply re-log into the device by selecting my same passkey. The operating system says, is that still you? Prove it's still you by presenting the same face. Here I am back into the app, logged in, unencrypted, access to my data. No servers involved. Now, WebAuthn does generally get used with an assumption that there's a server involved, but this is to prove that you can use WebAuthn with no server whatsoever. So I believe it can be one of many pieces of a foundation of a local first identity that does not require some proprietary server standard. You can build these things directly into what you put on somebody's client. Okay? I wanted to show another demo while I'm here. This demo is another piece of the puzzle. Maybe zoom in just slightly. This is another piece of the puzzle, and I'm gonna load this up actually just so you all can go to the same thing. Before I actually do the demo. This is the link to that demo because I want you to actually do the same demo here. You're gonna see some stuff displayed on the screen, and I'm gonna hope that you're able to scan that information and see the data. So if you wanna play with this demo, I hope you'll load this one up. This is another library that I wrote. Specifically, the goal of this library is to use what are called animated QR codes. Sounds really fancy. It's just static QR codes that are shown in rapid succession. But you can transfer small amounts of information through animated QR codes by having a camera that's watching the QR codes that are coming through and using them as frames of data and then reassembling the package of data on the other end. Again, no servers involved. So this demo is going to show doing that. So what I have here is I'm going to do receive data. So my device is popping open my camera and you can see me there. There's all kinds of copies of me up on the screen. But I have that same app open here. And what I'm going to do is do the other one. I'll show you this in a minute, but I'm going to do the other one. I'm going to type in some data to send. A note for the meetup. And I'm going to start sending that. And I'm just going to, before I show it in the camera, just so that y'all can see, this is an animated QR code. It's 5 frames of QR data. It's the data I'm trying to send, generated as QRs, and then rapidly shown in succession. This library handles the creation of the QR codes from a piece of data, which could be unencrypted or encrypted as just random text. And then it has the scanner that when I hold this up, hopefully it'll be able to read, there we go. It read all 5 of those frames and it reconstructed that data down here at the bottom. So why might we use something like this? Well, how about synchronizing your identity between your devices? Set up my identity under VelaAuth, and then I want that same identity, that exact same cryptographic identity that I can take with me around the web, but I want to synchronize that to all of my different devices. Well, then I could just click something that takes all of my encrypted identity information, displays it in QR form, hold up my phone, hold up my tablet, and boom, all of those have been synchronized and they never had to touch a server. So what I'm doing here is trying to illustrate that I'm working on the pieces. This is not a full and complete solution yet, but I'm working on the pieces as my contribution to Local First to try to create a way for us to have a truly local first identity, a truly zero server required type of identity solution. And I'm going to be building this into the apps that I'm working on and creating these libraries. But the main thing right now is that there's a whole lot of pieces that are kind of rough to fit together and they're just kind of in the demo form. So the main project that I've started on right now is to build a wallet app. Again, wallet sounds like it has something to do with crypto. Doesn't have anything to do with crypto inherently, although you could store your crypto credentials in there as well. But a wallet is kind of like 1Password or some of those other password managers, except it's specifically designed to integrate with local first technologies. So you're going to be able to do the WebAuthn like I just showed. You're going to be able to synchronize your information between your wallet instances using QR code. Oh, and by the way, there's lots of other ways that you can transfer data between devices, not just the QR code. That was just a nice, fun one for demoing. But we have Bluetooth. If you use a native app, you have full access to Bluetooth. There is a web Bluetooth API, which unfortunately is a little limited right now. Maybe it gets better. We've got NFC. There's also a web NFC API, but the native one is better. Did you know you can actually use sound? There's a library called silent.js that came out years ago, but it actually creates supersonic sound waves and does the exact same thing as the QR code demo that I just showed you, but it used sound waves to do it. So it uses a microphone and the speaker to transfer data between devices. So what we're talking about is there's a whole bunch of different ways that somebody's 2 or more devices could synchronize their information between each other. And that's what I meant when I said there are ways that we're going to solve the zero server signaling problem that exists around things like WebRTC. We're going to be able to build up higher level APIs on top of it. And what I'm going to do is try to roll all of that stuff into nice, simple, and completely free wallet app that you can install on any of your devices, native or web. And it's going to have all these capabilities built into it. And even if you don't use any local first apps, it's hopefully going to be a better version of something like your 1Password because there's no server involved. It's just your devices holding your credentials. That's better than sticking stuff up on a server that somebody can be down or somebody it can be a target for hacking. So as I finish, the last link that I wanted to show you was, let me pull this up, a blog post. Oh, I'm sorry. There was one other API that I wanted to talk about. This is a link to that spec. This is local peer-to-peer. This is an actual spec at the W3C that they're working on. They're trying to bring this API natively to the web platform. I'm a huge fan of this. I cannot wait for this to land. Might still be a year or 2 out, but they've made some really good progress. What they're trying to do is enable a cross-browser way for the website to hook into things like Bluetooth or NFC or any of the other cross-device bridges and be able to do direct peer-to-peer, kind of like WebRTC, but without any signaling whatsoever. So they're trying to put that standard API directly into the web platform. And if that lands, I mean, this is game over. A lot of the stuff that we're trying to create, we won't even need anymore because devices will be able to talk directly to each other, even from the web platform. But I will finish by showing you a link to a very rough draft blog post that I've written. This blog post is kind of the rough thoughts that I was sort of stream of consciousness jotting down as I was preparing this talk some weeks or months back. And it is a very rough draft, but if you wanted to hear more of my thoughts and a little bit more of a complete, maybe slightly more coherent than this talk, thought process around it, you might refer to that blog post. So the final step here is that I've been putting a bunch of these pieces of text on here, and I'm not suggesting that the text of my really ugly slides here is helpful to anyone, but if any of you want the text of that data, feel free to scan the QR code. It's just 14 frames. You can have the text of the slides that I typed in. You might have to hold it there for a second. It already has built into it that if it misses a frame, when it comes back around, it picks it up. I'd have to hold it for a few seconds, but it should be able to get all those frames. This is me sharing information with you with no server involved, okay? Proving to you that even something like a presentation can be done that. I started out thinking, oh, I'll build this all in Google Slides. And then I thought, well, that undercuts my message if I have to use cloud software to present to you, right? So this is definitely low fidelity, but the proof is that we have the building blocks in place. Some of you are still scanning this. Sometimes people are closer with their cameras or zoomed in or whatever. Hopefully that works, at least for some of you. And the final thing that I'll show is if you want an even fuller version of that information, I'm just going to give away all of the notes that I used for this talk. So, like my speaker notes here. This is everything that I just used to present to you. So I'm going to put this one, and it's going to be quite a bit more QR codes, but (101) frames. But if any of you are able to scan those 101 frames, I'll just finish up while some of you try to scan that. That has some of those URLs in it. If you missed any of those QR codes, it's got all the URLs in my notes. Things like that. You might have to hold this for 30 or 45 seconds because it may have to go through. Should be able to read all of those frames and get all of my notes. So in summary, what I'm concerned about is that we've assumed, almost in the sunk cost fallacy way, we've assumed that the way the web is built right now is inherently the web must be client. What I'm suggesting to you is there's nothing inherent about the web that's client server, because the web was built for clients and servers. And we can go back to a better version of the web, which makes servers optional, and in some cases, no server at all. There will still be some servers. I'm not suggesting that we're never going to have any more servers ever again. There's going to be legacy services. You're going to want to still do things out in the cloud, like, for example, serving up a huge video file off a CDN. You're not going to do that stuff peer-to-peer. You know, if you're going to run giant compute to do training of an LLM or something like that, that's still going to happen in the cloud. They're still going to make their money off of that. But the majority of what we do on the web, and especially the data that we interact with and create in our devices, we can own that stuff and we can keep it on our device. Even things like app stores, right? App stores are like this centralized set of servers that host all the binaries for our apps. But why do we need app stores? If you see an app on my device and you see me playing it, maybe it's a game or something like that, or a productivity app, and you're like, that's a cool app, I want that. Why can't my device send that app directly to you without any server middleman? The pieces of that are actually not that far-fetched. They're almost in place. And that's what I think Web 2.5 is going to become, is the web where our devices talk directly to each other, and for the most part, cut out those evil middlemen. Hopefully this has been interesting information to pique some of your thoughts. I'll stick around and answer any questions if anybody has any thoughts. Or you want to tell me if I'm crazy, that's fine. But thanks very much for listening. I appreciate it.
All right, thanks, everyone. We have a few minutes. So feel free to come say hi if you haven't. Otherwise, thanks for coming out, and hopefully we'll see you next time. Appreciate it.